Okay, let's review. We highlighted the math concepts of ratios, measurement, and graphing. Dr. Crouch applied the concept of ratios to help us define microgravity. And Dr. Olson explained the importance of measurement and graphing while conducting spacecraft fire safety research. Now it's your turn to apply these math concepts in your classroom. Check out this program's awesome hands-on activity.
Hi, we're students at Northside Middle School, here in Norfolk, Virginia.
NASA Connect asked us to show you this program's hands-on activity.
You can download a lesson guide and a list of materials from the NASA Connect website.
Here are the main objectives.
Students will apply techniques to determine measurements, use metric measurement, build mathematical knowledge through investigation and experimentation, collect, organize, and graph data for analysis, build an understanding of microgravity.
Good morning, class. Today, NASA has asked us to investigate how graphing techniques are helpful in understanding the concepts of position, velocity, and acceleration.
Teachers will find a location for dropping pre-selected objects. A set of bleachers provides a good variation in heights without using ladders. Mark the drop location in even increments, if possible. 8 to 10 drop stations create a good graph that students can easily view. Measure each station in meters or inches and use the conversion 1 meter equals 3.281 feet. Organize students into groups of 4. Once each group has selected a different ball to use for all their test drops, distribute the student materials. A student recorder writes down the height of each drop station on the data collection chart. A student timer records 5 drops at each drop station. Only the ball dropper should climb to the drop site, with the rest remaining at ground level. The student counter returns the ball to the dropper and begins the countdown again when everyone is ready. Average the times for each drop station and record on the data collection chart. Square the average times for each drop station and record on the data collection chart. Using height and average time data for each drop station, plot a distance versus time graph on drop data chart 1. Using height and average squared time data for each drop station, plot a distance versus time squared graph on drop data chart 2. The teacher will collect the drop data charts from each group and compare the data on drop data chart 1 for each ball and discuss the shape the data points create. Next, overlay all drop data chart 1 transparencies to compare the data simultaneously. In the next comparison, compare the data on drop data chart 2 for each ball and discuss the shape the data points create. Again, overlay all drop data chart 2 transparencies to compare the data simultaneously.
It's time for questions. Based on your observations, predict what will happen to the acceleration if the object is dropped from a greater height. Christine.
I don't think it'll matter where you drop the ball from the bleachers, the acceleration will stay the same.
Great answer. Mr. Coppola?
Thank you. Did the shape or surface of the object dropped have any effect on the results? Explain. John?
I don't think that it would have any effect on this experiment because we're using an object such as a ball, and the air resistance is negligible. But, on the other hand, if we were to use an object such as a piece of paper, it would float down and take longer to hit the ground.
Teachers, if you would like help to perform the preceding lesson or any other NASA Connect lesson, simply enlist the help of an AIAA mentor who will be glad to assist your class in these activities.